Alright, greetings everyone. Welcome back. So previously we investigated socket verification. What we're doing here is more or less the same, but for pipes. So let's get into it. Firstly, we need to find the office that we're investigating, or if it's a person, we need to find their identification. Identification. Yes, right? And then so that we can be able to trace where they've been and what they have been up to. So in this case, we find the process ID of Firefox. Okay, and like the usual, we ask, what are you doing? Okay, are you working or not? And they say they are running right now. Brilliant. Now they are sleeping. And I think it goes without saying, this is a running process. Even if we were to like to pause and find the user time versus the system time, you most definitely get to find that it's increasing. Simply means that this is a blinker. But well, okay, we're not there. Let's break this down. We find the unit of the office that you're investigating, or the ID of the person that you're investigating, and we ask, what are you doing? Are you working or not? And in this case, let's run with this and say, I'm not working. I'm not working. And we ask, what are you waiting for? And they say, poor schedule, time on. So yeah, essentially telling you that we are event driven, my guy. We are waiting for something to happen, or the delivery to happen, so that we can do our work. Okay. Essentially after this, or immediately after this, what at the back of my head is, well, is what are you waiting for able to reach you? So given the fact that we are investigating pipes, this is how we go about it. Is what you are waiting for able to reach you? Given the fact that you want to see pipes, please show me pipes. Boom. Right. So peer verification in this case is, here's how pipes work. They are unidirectional, okay? They are one-way street. Think of this as walkie-talkies. There can only be one person speaking and the other listening. That's exactly this right now. What we have is, we have a writer and a reader and a writer. A reader and a writer for every single inode. That's it right there. For every single frequency. In this case, in this logic, there's only a reader and a writer. That's it. And I think it goes without saying, what happens if I come across a single reader or a single writer? Well, from me to you, go out there and investigate what happens if you find a single writer or a single reader when we have pipes, especially with inter-process communication. Okay. But let's say you come across such a situation, you still need to investigate further and make sure that, well, for real, this pipe is alone. So the very first thing, let's investigate this right here. Right here, we know for a fact, we can already see for a fact that, well, there's a reader and there's a writer. So this is a healthy, structural integrity. This is top notch. It's exactly, it does and work exactly as it was designed. But if you found one and you wanted to investigate, this is how you would do it. It's like the anode that you're investigating. On every single open file, please find me this anode. Show me two. I didn't write that on. Now we're gonna see a plethora of open files saying, I got it. Jeez. Alright, no, for this loading. And we need to figure out why this takes forever. That's a lot. That really is a lot. Anyway, if you wanted to do that with less headache, or less waiting time, this is how you do it. Are you gonna take forever? Yes, no. Go? No? Genuinely, but we need to figure out why does that take forever. Right, so there we go. We have two pipes right in here. We have this one. He's a reader, and he's reading from 72, and 72 is writing to 70. There we go. And honestly, this is very local. If you wanted to do the very same thing, but globally, so meaning for every single process that is running on this computer, this is find me this inode and show me their peers. So this is 0, 9, and then there we go, and then we grab process pipe. So let's hypothetically that you're investigating which node. Let's find you an node that you can utilize. Let's find you this one right here. Ooh, not the we don't want that another one. We need to take this whole thing.
What is this?
Cool.
What is this?
And then we do
What is this? What's that?
something. What crap? For every single file that is open, for every single file that is running on this process, get me a pipe that has. Ooh, what do we do? This is what I missed. True. There you go. There you go. But if you wanted to find if whether the data is flowing through the pipes, this is how you would do it. So firstly is we need to find the status. What's the name of the office? In this case, we need to find the name of the office again. Right. And process. No, not true. 6 status. And then we grab this whole thing. We are saying for getters switches. Right. And here, if there's anything you can see, you can tell for a fact that you have voluntary switches that are increasing relative to non-voluntary. What this tells you simply means that the pipes are working. What we have is we have threads that are going onto the CPU, doing what they need to do. How do I explain this, man? Okay.